Madam, good afternoon. उनका चेक रेडी।
Good afternoon, madam, and good afternoon, all participants.
Hello, sir. Hello, sir.
Madam, shall we wait for 5 more minutes or shall we begin? We have 14 participants, 13. Shall we wait for 5 more minutes?
We can just, I will not start anything. Maybe, yeah, if the participants want to just know anything or if they have anything.
All right, so I'll formally, open the session here.
We can take, or else we'll wait for 5 minutes.
Welcome all to the day 3 of the workshop on quantitative research using SPSS and AMOS. We welcome Umila Jagadeshwari from CMS Business School, Bangalore. Thank you very much, madam, for joining with us and taking us through the tools and techniques of quantitative research, especially the factor analysis. So I leave the platform to you now to take over. Thank you so much. Meanwhile, if participants have got anything to share before she begins, you're free to. Thank you so much.
Am I audible?
Yes, you are.
Yeah. Thank you for introduction. Yeah, I can see some of the data which I have shared and the PPTs and the information which I have shared. They all got the access for the drive now. Sir, I've seen few messages that they don't have access for the drive or something.
They have an access now. They have an access.
Okay.
So your voice is breaking in between. At times it is breaking.
My voice is breaking. Yes, I think, I don't know. Just give me a minute.
Sure.
Is that fine now?
Yeah, looks fine. Any one participant can also respond.
Yes, sir.
Okay, fine. Thank you for your response. Any specific
Fine, ma'am, it's fine.
questions? Yeah, thank you very much. Like, because I understand that all of us are academicians. End of the day, the purpose of learning these technicals is because of that we want to complete our PhD or do some good research work. So my emphasis for the next 3 days is completely on that, it's not simply understanding and learning the technicalities. It's all about like how are we going to use them in our publications, where to start, and how to make our publications little strong. So these are some basics, more than technicalities. I will definitely share the practicals as well as, but however, that I'll give you, first some kind of a theory because you should understand that, and then we will do some simple practices, and then I will give little more theory, and then we'll go to understand, do little more rigorous practicals. So maybe by end of the third session, that I'm sure that you all can do simple factor analysis, exploratory factor analysis, and the confirmatory factor analysis using SPSS and SCM. So apart from this, any other questions you have? Because I cannot go back to the previous sessions because factor analysis, EFS, EFA itself is too much. That anything, your expectations, because I have come with papers also to show you how to start and all. So I think I have enough information that if all of you are ready, that we can start.
Yes, ma'am, we are ready.
So what do you say, Nagendra sir? Shall we start? Because it's already 5 minutes.
Yes, we can begin, madam. We
Yeah,
can start.
definitely.
Thank
So how many of you are PhD scholars who are in the process of doing your research? How many of your professors who wants to start writing some good impact, good papers which you want to publish in an impact journal? So these are two questions I have. The thing is, you need not to interact. If you feel that you have some obstacles to interact with me, you can even put in the chat. That's fine. Because as per my thing that I consider many of your research scholars, professors who wants to develop your thesis as well as publications. Am I right? Yes, no?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Okay. So, well, when do we use factor analysis? Because the moment that these kind of terms, when we hear factor analysis, exploratory factor analysis, confirmatory factor analysis, that, many times even research scholars ask me, ma'am, is it really important for us to, understand these concepts? And also I have a couple of questions like factor analysis, EFS, EFA are used for scale development. So if I'm not developing scale, that do I need to use this? Right? These are certain questions generally people will have that. So I will start with what are the different types of research articles or research works that we can do by using factor analysis. So basically, if you see, there are a couple of papers which I have already uploaded in the drive for your quick reference, that I will start with a simple paper and then I will go to a little complex paper, as I have seen few message that you want to also see something from the um, finance perspective. So I have got one paper also from the finance perspective. So you can start exploring from that way. So if you take this particular paper is not about scale development. It is about a researcher wants to prove that the relationships between terms where they employee branding, TQHRM, and sustainable employability. I hope the screen is visible, right? Because I want you to involve with me, then only I will get that feel that you all are following me.
Absolutely visible. You go ahead, ma'am. No problem.
Thank you very much. Yeah, so now you see this particular title. So this is a B category publication. This is not too complex publication, because why I want to start with this publication, we have not collected a lot of information. In fact, you can see that's my paper only. You can see that this paper has only come for 3 times revision, although it is at a B category. It took kind of, like you can see that I have submitted in the month of 31st March, and then it got accepted in September. So 6 months process that the paper got accepted and published also. So why I want to tell that, I want to ensure to give you that confidence that factor analysis, CFA, EFA is not a rocket science that which we can't do. It's all that if we understand when to use this, how to use this, and if we can able to understand the flow of complexity of this particular technicalities. Like, so this is the simplest way that we can use exploratory factor analysis and confirmatory factor analysis to write a paper. So here there are three constructs. So employee branding, TQHRM, sustainable employability outcome. So the researcher wants to just prove they have developed a simple model, very simple model. This is the conceptual model. I hope all of you know the difference between a theoretical model and a conceptual model. A theoretical model we will show using a theoretical support. So you can consider this as a simple theoretical representation that, employee branding practices, TQHRM practices, and sustainable employability outcomes, where this is the construct and these are the variables in that. In fact, you can see this is first order and second order. I will tell what is that first order, second order. So technically, if you see here, TQHRM mediates. It's an intervening variable. So this is a theoretical representation. How this can become a hypothetical representation, that if you are the same, it's a simple three construct model where you have EB as an input variable, and you have your TQHRM as an outcome variable, and you can see some sustainable outcome, TQHRM as a mediating variable, and sustainable outcome as an outcome variable. So just three items that you can, three constructs, you can collect some data, and you can definitely establish a model using EFA and CFA. So what is the difference? Say when you are trying to develop a scale and you don't know whether those items are used in the current context, whether in your country or in different country or for a different product or something. In such cases that we have to undergo the scale development process, where that is different from using EFA and CFA for simple model developments like this. In fact, we term this as a path models. Okay, so this path models we will develop in CFA, but however, you might think that what is the role of EFA? So although we do all these things, and we sometimes questions that, generally when I get certain questions like, ma'am, during scale development only that we should use this EFA, CFA. No, even though the scales. So if you see in this study, we have taken scales which are existing. So you can see here, employee branding, brand oriented communication. This is the scale which we have taken from King and Grace, Punjeshri. So the scales are already established scales. These items are taken from different studies. So when I have my items are in place, I no need to apply all the steps of scale development. When I will apply all the steps of scale development, when I am generating items, when I am developing my own statements to collect data. So here in this case, I am referring certain papers. From those papers, I am taking those statements. All the three construct scales are developed from an existing scale. So you can see all these elements are taken from an existing scale. So when I have taken, elements from the existing scales, you can straight away take this part. I will come back because when I'm touching on basics, I will come to this point. And you have to run a simple EFA as well as CFA. And you should show those factor loadings and you should confirm that they have satisfied the basic requirements. That's all. That they have satisfied the basic threshold points. And you should show in the process, like during the first stage, which is exploratory factor analysis, which are the elements we have deleted. At a confirmatory factor analysis, which are the elements we have deleted. That you can think, ma'am, first of all, we don't know what is exploratory, confirmatory, and all these things. No, don't worry. I will give you the meaning, but however, why I'm using these terminologies, that you will be well versed in the process, that you will understand which terminology comes first. So the process first, exploratory factor analysis comes first. Confirmatory will come in the second stage. Exploratory is something that we explore and tell that if I have 20 items, all the 20 items satisfy the threshold points, or only 18 satisfy the threshold points. And in confirmatory, by keeping all those items in a directional model, and I confirm all 18 items I have considered to develop this model, or I have deleted 1, 2, 3, 4, some 4, 5 items I have deleted, and I have considered only 15 items to construct this particular model. So I hope I can able to, I tried, setting a context. Any questions at this point? I will not go a little deeper because all these are little deeper, that which I will discuss in the later stages. Yes? How many of you have got confidence that we can make simple models using EFA and CFA and still can publish papers? Even you can even do research, thesis work also. Any questions? No, yes. No questions?
No, ma'am.
Okay.
No,
So,
ma'am.
all of you know about this?
Yes, ma'am.
Fine. If you know, it's well and good. Yeah. If you see this developing and validation of behavioral basis scale, a SEM approach. So
Excuse me,
here,
ma'am.
yes,
Ma'am, have you shared this papers with
everything
us?
is shared. Everything is shared.
Thank
Okay.
you.
Yes. So if you see, there's one more paper. This is an actual scale development paper. We're using SEM, structural approach, where you can see here also, I will explain you. I will just show certain things so that you will understand the difference between those two papers, that paper as well as this. So if you see here that they have 3 constructs, which is cognitive biases as well as emotional biases. Methodology. Results profile, yeah. So you can see here from the literature review, they have taken items, but still they want to develop the scale, assuming that they have identified from the literature that these scales may not be tested in the context that they want to study. So in such cases that they can always take the existing scales and also develop they can redevelop. So if you see here, there are few items, item added through this study. So if you see here in the construct availability bias, not all the items they have taken from the existing literature review. They have developed few items which they consider that in that particular context, whichever the context they are studying, that particular item is important. So they have developed that statement. Because they have included that statement in this particular construct, so this particular paper is considered as a scale development paper. So now you can come to an understanding that you no need to develop completely a new scale. You can also take an existing scale. You can also take an existing items. But if you feel that 1 or 2 more items need to be added into that particular construct, in such cases also that we are going to do we will use exploratory factor analysis as well as confirmatory factor analysis. Right? So here you can see the same way, the first things first, that first anybody has to run an exploratory factor analysis, check the factor loadings, and all satisfies this threshold, and then they do a confirmatory factor analysis, and then they will also show the factor loadings if based on the satisfaction by checking the construct reliability and all, they develop the scale. So this particular process is little rigorous. So here in this case, there will not be any compromise. So
Hello.
yes.
Hello, ma'am. Sorry to disturb you. I had just a question. Is it important that you run both exploratory and confirmatory, or only can we directly do it with confirmatory?
No,
because
we cannot.
My model, my theory is supporting, so I can directly go for confirmatory, right?
No, you can't.
You have to run both exploratory and confirmatory. Both you have to run.
Yes. You have to run an exploratory factor analysis. Without running an exploratory factor analysis, you can't confirm. That's what I mean to say. Without doing the data preparation, without doing the basics, you can't do an advanced. That's it. That's why I'm showing these 2 examples. The reason behind, I have not straight away introduced what is factor analysis and all these things. I'm just trying to, first set the context by showing the papers and showing the difference.
Okay, ma'am. You can go ahead. Thank you.
Yeah. So here you can see that in that case, we have used path analysis to show, that means at last in the confirmatory factor analysis, we have shown some paths, like means A leading to B and B leading to C. That's a model testing. Here we are not testing model, we are only developing scale. So you don't have models over here. You just only check whatever that factors you have explored, you will check using a confirmatory factor analysis. You just develop a measurement model and you tell to the readers that your scale is eligible to measure what it tends to measure. So that's what we do. There you tell to the readers that your model, this path is successful, this path is significant. But here you say that the scale can be used, this scale is now fit for measuring in different contexts. That's what, as a researchers, that we will tell to the readers. So any questions at this point?
Ma'am,
Yes, ma'am.
actually,
Yes. Swati Rani, I will take
yeah.
Swati's question. Yeah.
Ma'am, actually, I'm a research scholar.
Mm-hmm.
So I'm in the prelim form of like doing the coursework.
Mm-hmm.
So I am not able to understand, like, I understood that scale can be tested and everything, like you have shown from the literature review. So how do we say that it is a scale and every scale should be measured? Like, I am not able to get that.
What is that every scale to be measured?
Like,
I did not understand your question.
scale from, like, what do you mean by a scale? Can you just tell me that? Like, I am not very much clear about the term.
Okay, when I come to basics, I will talk about scale. Okay, I
Okay,
will
okay.
tell. Okay,
Yeah.
Third type of paper that generally in factor analysis.
Excuse me, ma'am.
Yes.
Ma'am, with regard to the secondary data,
Mm-hmm.
when we have the concept clear and we do know what is the dependent variable and the independent variable, can we directly go with the CFA?
No, we cannot do. That's what
We
I
have
mean
to
say.
eliminate, going through EFA, then only go for CFA, is it, ma'am?
Yes.
Okay, thank you.
Yeah, any model cannot be tested straight away doing a confirmatory factor analysis. The factors has to be explored, whether those scales are already existing or new scales. Yes.
Thank you, ma'am. Thank you.
Yes, yes. Yeah. This I have Andy Field as per my readings, whether I check in Andy Field or I check in Higher et al. All these books will definitely help you to process in the same way. Or online, you can just go with the Gaskination StatiWiki webpage and just understand how James Gaskin explains that all of these professors, all of these books tells the same thing. It's not, Dr. Urmila tells that it's our written in books. Okay. Now the third, this particular paper is little rigorous paper where you see a first order and a second order set of items. Right. As I understood that a few participants need to understand what are called items, constructs, variables, and scales. So these terminologies I will explain, because today I even got the basics PPT also, because I'm sure we, based on the diversity of the participants, we face this kind of we need to have this kind of a discussion. I will show that. Yeah. So this, I will not spend more time on this. This is at a higher end. Maybe once you learn EFS, CFA for developing simple models, and then second stage, you go develop scales. And in third stage, you can develop a second order, first order, second order scales. I'll just show how those first order and second order scales look like. Okay. You all can read these papers, because as it is difficult, I cannot explain the entire paper, but all these papers are fantastic the way they are. So you can see here, these are constructs. I'm not going to explain what are these constructs. This is anything which is representing in this oval shape. Those are called as constructs, or we call it as dimensions. Anything which is represented in this rectangular box, we call it as variables or items, right? Variables, when questionnaire, when you are collecting data, each question is called as questions. And then when you're converting them into data in the Excel sheet, we call them as variables. When you do basic SPSS, descriptive statistics on them, that we call it as variables. But when you conduct factor analysis, EFA, CFA and all, we call these boxes as items. So that's where the understanding. So these are nothing but your questions. Okay, the questions which you have captured in the form of numerics, which are nothing but variables. But when these variables are grouped under categories like this, so in that stage, we call these oval shapes groups as constructs, and we call these boxes as items, right? So in the conceptual language, these are dimensions, these are the variables, these are your questions. I hope I'm clear now. So if you see here, this is first order, right? The researcher wants to develop a employer branding scale. Okay, so there is a first order will come here, which I will show. You can see here employer brand. So basically, the researcher want to develop a scale for employer brand. However, researcher understood that employer brand collectively, all the 20 items cannot together in one order. I cannot define employer brand. So employer brand is a combination of these dimensions. This is first order, this is second order, and each dimension is again having items. So in this way, a researcher has to study. First, the researcher has to prove the first order model like this. This is a measurement model for the first order. Once this measurement model is confirmed that whatever the requisites are fit, then the researcher will go and develop a second order model, this model, and then check, even after adding one more element, one more construct like this, whether this model is fit or not. After checking the significance and fit statistics, if it is fit, then finally the researcher will confirm that this scale, employer branding, is a combination of, one second, I'll just show. Employer branding is a combination of these dimensions, and these dimensions are formed based on these items. So basically, you take financial management definition or human resource management definition, that you will have, first stage is like integration, development, compensation, like that. So these are groups, and all these groups comes under a complete umbrella called human resource management. Again, you say in the under integration or under acquisition, that under acquisition you get recruitment, selection, and all. Again, under recruitment you have certain statements. So your dimensions are expandable. If you are making such kind of a complex models or such kind of complex items or constructs that dimensions you want to study, in such cases, this is little complex understanding. So I know it is too early for all of you, but tomorrow when you download a papers, that if you see this, that you immediately, it should not scare you and stop, that we start resisting studying factor analysis when we see such kind of complex models. So that's why I started with a simple model, that to motivate all of you, that we all can learn EFA, CFA for developing simple models. Okay, so now I will stop sharing the screen. Yes. So before we go to basics, any question related to those three examples which I shared, you can ask me before I go to the basics. I hope the flow going fine. No questions?
Yes, ma'am.
Yeah, thank you. So now we'll start with the basics first. So to do any research, first we should understand the data processing. Okay, how do we what type of data processing we generally need to do? So on your first 2 days that you have you have seen working on some data which you have imported from Excel to SPSS. You have done, I understood that you have done some outliers. One second. Yes, outliers, and you try to do some basic descriptive statistics and all these things. But when you are doing a paper, when you are doing a research paper, these stages are very, very important. So these are the stages that we should keep it in mind, that when we are running an empirical works, when we plan that we are going to develop an empirical paper. So first, the data collection phase, second, the data analysis phase, and the third is the data analysis phase. So we have 2 different types of phases here. In the data analysis phase, the first is the descriptive statistics. When I was showing those papers, I have seen you, even though they are developing skills, their first information they kept is all about the descriptive table, one descriptive table. That is important and mandatory for all the research papers, irrespective of the outcome or the study which you are doing. Your first basic data analysis must be descriptive. And I will tell you what type of descriptives that you have to do it, and what type of descriptive tables that you have to put it in your research articles. That, you must have done so many things, like, frequency tables, or, the basic skewness, kurtosis and all. What exactly, when it comes to factor analysis, what tables that you need to put? I'm not talking about for other studies. Whatever that I'm explaining you, my entire intention is that end of the day, you will be developing a factor analysis, based papers, not other papers. Okay. Again, you may have a doubt. Even for another paper also, I need to write like this. No, if I'm only talking about that for an EFA, CFA paper, you should have descriptive stats also in place, how you need to show such kind of information on your articles. That's it. Okay. So inferential, descriptive and inferential statistics. I believe all of you know the difference between descriptive and inferential statistics. Yes, no?
Yes, yes, madam, we know it.
Yeah. So choosing the appropriate coding method. So basically in the first stage, why it is important when you are collecting data, that you should know what type of data you're collecting. So are you collecting the qualitative data and quantitative data? Why I'm bringing this context of qualitative? When you are developing questionnaire, and when you are telling that you are doing a scale development process, we as a researchers, particularly this is most applicable for the scholars who are starting their study, that you should first start your study with I don't say you should. It is good that if you your research will be grounded strong, that if you start with a qualitative research and go with a quantitative research. That's what you see here, the two types, which is exploratory and confirmatory. And couple of you have asked, ma'am, can I straight away go to confirmatory? Absolutely no. As I mentioned, that you have to first do an exploratory and confirmatory. So this exploratory we do from two perspectives. One as a qualitative exploratory study, and second as a quantitative exploratory study, which that's what I'm going to show here. So you can, yeah, the terms look very too deep, I understand, ontological, epistemological, all these things. But for your simple understanding, that if you are observing, or if you know that there is no scale for that particular behavior or a scenario, in that case, you observe certain behaviors, develop some scales, go back and interview few people, and from there you develop some themes and pick up those keywords, and then finalize your empirical questions. That is technically we do, and I suggest for the thesis work for sure. And also I suggest that if you are developing a complex scale development process, that qualitative study in the first place is very, very important. Now we'll come to a quantitative understanding. Quantitative studies are used, we generally use quantitative studies to confirm our research questions. To explore research questions, we have to use the qualitative studies, which are open-ended in nature. So here we use a descriptive, rational, or a causal. So descriptives, that as you all know that how your data looks, that you are going to describe how your data exactly looks. Relational is more of an inferential as well as causal. We see cause and effect. In the path diagrams, we generally see those kind of relationships. So basically, if you see your codings, when you have to code your data, you have to code based on what type of data you're collecting. So now we all come to an understanding that we are collecting an empirical data. I'm not talking about a qualitative data right now. We believe that we are collecting an empirical data. Just we'll go forward. So when we collect an empirical data, as one research scholar is asking me question scale and also I will explain now, so that you will have an understanding now. So first we need to do the data processing. So what data processing we do? First, we should have a data editing step. In that, variables. As I mentioned, variables are nothing but your questions, like your demographical variables as well as your data, construct variables. So your demographical variables are nothing but age, gender, and all these things. As your questions are whatever the model you want to test, those are your questions. Now, what is scale here? For example, if you want to study about a construct called joyfulness, that's it, a construct called joyfulness, and you just go to a joyfulness literature review, and you search that how to measure, because joyful, something which we cannot measure by seeing a person. How can we ask that are you 100% joyful or 70%, 80%? You assign certain questions. What make you joy? Like, what are the factors or which elements? Why are you happy? So when you ask such question, I am happy because of this or because of that, or how much happy. So you'll ask certain questions, right? Those are nothing but the scale which you want to measure the happiness or joyfulness of about a respondent or anything. So that is nothing but a scale. So as I was talking, employer branding is a skill that you, if you want to use that scale, the scale which is developed between 2023 paper, you can straight away you can refer that particular person, and you take all the elements which he has developed, and you can test it in your context. So basically, to study a particular construct and what items come, that are you going to develop those items? Then if you are going to develop the items, then you need to follow the entire scale development process. It is too difficult. So in such cases, you will go to an existing scales, right? Those existing scales are nothing but scales which are already developed by somebody. So what is a scale? A scale which is used to measure a particular quality. Like, how do we use a typical scale? A scale will tell us how many centimeters of this pen or mobile or whatever it is. Similarly, a scale which we generally use to understand or study about a particular context. Okay. So variables we should have. Variables are nothing but our questions, and those questions, when we convert them into data, those are called as variable. Data matrices are nothing but the tabular forms which you have on your columns and rows. What information that you keep on the rows, you have your respondents, on the columns you have your headings, which I will show it. Each line is a separate case, so we call it as a case. Each column is a variable. So what is a variable? If I make gender, age, gender is a variable, age is a variable, question number 1 is a variable. But on the line, on the row part, if I see respondent 1, respondent 2, respondent 3, these are called cases. I hope I am clear now. You can read this. This PPT is there. You can understand this. Each cell contains one and only one number. Yes, this is how. So this is the column where you have variables over here, and the rows where you have cases over there. I hope I am clear, right? And types of data. So how many types of data we have? We generally have nominal data, ordinal data, which are also known as ranked data, scales, measures. So basically nominal data is nothing but gender, which will not have any order, but we want to understand them, male, female. We cannot give an order to male or a female. So many times scholars ask me, ma'am, M should come first or F should come first. So what is the suggestion I suggest? Even the books also suggest, as per the alphabetical order, F comes first. So female, if you see most of the times in the questionnaire, A will be females, B will be males. For our researchers' understanding, I'm telling this, but however, there is no order. So you no need to worry about what order I have to keep it. Occupation or these kind of questions, if you have, there is no order for such things. Those are all comes under nominal scales. Then the ordinal scales, which are nothing but our Likert scale, 1 to 4, 1 to 3, 1 to 5, or 1 to 7, 9, as per the requirement of the study, you can. So generally, what is an ideal scale? That mostly used scale is 5-point Likert scale with a 5 order. But I suggest that, if most of your management researchers, if you can eliminate neutral, and you can able to justify such studies, eliminate neutral and go with an even scales will give more understanding, better understanding than an odd scales, with my experience I'm telling. But however, there is no such rule that you should use even or an odd, nothing like that, because of the comfort and keep the neutral in the center. See, the moment if a respondent gives you a neutral, then what is the point of doing such study? So yeah, I know end of the day we are forcing respondents to give certain things. So in such cases, what happened? Respondent will forcefully give a neutral. So if majority, you are collecting 200 sample, in that 100 people have given neutral for a certain question, then that question becomes redundant. It is irrelevant for your study. That is the reason if we eliminate neutral, we are asking, we use 4-point Likert scale, 1, 2, 3, 4. 1, 2 is bad, 2, 3, 4 is good. I mean, the positive scale, if you say the positive side. So if he is unhappy, he either prefer him to position himself in 1, 2, or if he is happy on a particular statement, then he tries to position himself on 3, 4. I hope I am making sense. That's why I'm suggesting that always go for a even Likert scales, which will help you to have a better understanding, like in-depth understanding about your study. This is my suggestion, right? So these are scales and measures which I have explained. Open-ended questions and all for your readings I mentioned. Missing values, yes. With the data, I will do the missing values, but basically missing values you must almost know by this time that values can be missing for 4 reasons: not applicable, refuse to answer, do not have a view, just missing. Maybe they fail, sometimes they fail to do that. So when you are doing it in Excel to understand, you can just replace the blanks with 99 or 999 or something, so that it will be easy as a researchers to understand which are the cells having a missing data. And later we'll see how we can impute, missing information and all for the factor analysis, which I'm going to show. Data cleansing, yes, very, very important to start with the factor analysis. Today's session is all about the data preparation part, which I'm going to tell tomorrow and give the introduction to EFA, and tomorrow we do the principal component analysis and EFA, both the difference and all these things. So data cleansing, yes, we need to avoid the ambiguities and inconsistencies in the data. So what kind of ambiguities? That we will have missing the values, we'll have outliers, we also have unengaged responses. We also need to check whether our data is normally distributed or not. We also have to check whether our data is heterogeneous or homogeneous data. So I'll show all those things, how it works, how to test and all. So basically, end of the day, we should have a coding sheet like this. All of us must have. Once you have a questionnaire sheet in your hand, before you filter that data into an Excel sheet, your sheet one must have a coding sheet like this, and you should be in a position to code them. So age, whatever the designations, for worker, I'll give 1, for supervisor 2, for manager 3. So you should have codes like this. You should have a coding sheet like this. Without a coding sheet, it is very difficult for a researcher to do the analysis. So first things first. So as I told, all the participants, when you start doing it, that coding sheet has to be there, right? And this is how the final, variable sheet looks like. So generally we write like this. So we can shorten those by giving A1, D2 like that. So you can start doing that coding part. So generally in the quantitative data analysis, what do? Quantitative data is nothing but a numerical data. It has to be more structured, because when we complete this editing process, our information is more structured. That's what we need to believe when we go to an inferential statistics. So less detailed on behaviors, attitudes, and feelings, that, because we cannot measure behaviors, attitudes, and feelings, so we will measure them using a scale. And larger sample sizes that represent a population. So in qualitative data, we go with the smaller sample sizes, whereas in quantitative data, we go with the larger sample sizes. Usually replicable, reliable research methods. Yes, the biggest advantage of quantitative research is generalizability. So end of the day, every study, every researcher asks, even the editorial asks that, what is the generalizability of your study? That whether you can generalize the study to this context or to this sector and all. If you can able to confidently mention, yes, this can be generalized to at this level, that's when, our publications, our papers will get accepted and we'll get the publications. So analysis of results. So generally, what type of an analysis we do? We do either a relationship testing or a difference testing. So what is the relationship testing? How one variable affects another variable. So you can see here, either we test this using correlation or regression. So basically, it's like there is a significant relationship between A and B. There is a positive significant relationship. So I hope all of you know one-tailed test and two-tailed test. So Where if your statement is there is a significant relationship, it's a two-tailed test. If your statement is there is a positive significance, so positive denotes to a one-tailed test, or negative denotes to a one-tailed test. So this is how the hypothesis statements we generally make. Then the second type of test we do is differences. What do we use here? We use ANOVA, t-test, and Mankova. We also use MANOVA. If it is non-parametric, we use chi-squares. So why I'm bringing chi-square here? That in structural equation modeling, when I say if we need to understand the difference between the models, we use chi-square analysis there. So which I'm going to show that time. But for your understanding, I'm bringing chi-square analysis here. Right? These are some tests that you should be knowing. In fact, you should know why these tests are used here. So basically, is there a difference between male and female? If you are making such kind of statements, we generally do this. Yeah. Yes. Hypothesis testing. So all of you know that we generally have a null hypothesis, which we don't write it in paper. We'll have an alternative hypothesis, and we'll have a directional hypothesis. Why I'm bringing directional hypothesis here? If you see in the structural models, we call it as path models. Path models are the directional models. We are going to prove or disprove those directions. That's why we call it as directional hypothesis. So what is a directional hypothesis? A is leading to B, or B mediates the relationship between A and C. These are directional hypotheses. Any questions here? Because this is something little confusion that you may ask me. Can you give me what is the difference between an alternative and directional? Any doubt here at this point? Yes, no. All of you can able to follow me or not?
No, ma'am. No question.
No question. So I hope all of you know the directional hypothesis.
Yes,
Can you please little more? Can you give please a little more explanation regarding this directional?
Yeah, I know that. That's why I asked you. I stopped here. See, for example, there is a significant relationship between A and B. Okay, so we'll make a null hypothesis. There is no significant relationship between A and B. The alternative hypothesis is there is a significant relationship between A and B. That's it. There is no direction here. A may be forwarding as well as backward, or A can be positive or negative. The relationship can be positive or negative, right? So when you make a directional relationship, there will be a significant relationship between A and B. There is a positive significant relationship between A and B, or else A leads B. A is causing B, or there is an effect or impact or influence, like how we can say training programs of something has an impact on performance of an employee. So the direction is first training is leading to performance, right? That's a directional hypothesis. So when you develop a model, you will develop a forward relationship, right? So that's if a direction is shown like that, in such cases that we generally use a directional hypothesis. Why I have got this? Because in the SEM models, when you are representing path models, when you are testing path models, you all will use directional hypothesis rather than a simple null or an alternative hypothesis. We are going to tell this. They say that there is a X mediating the relationship between Y and Z. So there is a direction. X is a mediator. So what is the direction? Y is leading to X, X is leading to Y, X is leading to Z. So there is a direction here. So to establish to prove such kind of an hypothesis, we call them as directional hypothesis. We develop such hypothesis. So that hypothesis will be broken into small hypothesis, group, like we generally, for example, there is a X mediates the relationship between Y and Z, right? So there are three variables here. So how this hypothesis is, first you test there is a significant relationship between Y and X. There is a significant relationship between X and Z. There is a significant relationship between Y and Z. If all the three relationships are significant, your mediation is partial mediation. If any of these relationships are not fine, particularly y and x and z relationship is insignificant, there is no mediation. But if the relationship between y and z is insignificant, but there is a relationship between y and x and z, then it is fully mediation. That's where directional hypothesis will come into existence. Okay. You can refer my paper and you understand these directional relationships. Hypothesis. Yes. So, yes, Archana, you have a question?
No.
Okay, thank you. Right. So, the next. Yeah. Next is this.
Actually, I'm actually developing one paper that is based on this employee branding only. So I'm in that actually that my model is like employee resilience is the
Archana, if you don't mind, if the question is only related to that, we'll ask, or else shall I take these questions little last?
So I wanted to confirm that whether it is how we can relate to those factors. That is what after listening your thoughts, what I felt is whatever I'm developing is much related to that. That is why I'm asking.
Okay, if you feel it's a directional hypothesis, yes. When I'm running that, maybe you can just try understanding, or else I will take the questions at last. No issues. I'm not telling that I will not answer you, but I will just take it little later. Okay, because we're still in the basics and we have already completing 1 hour, so I just want to little ensure that we will serve the purpose. I will serve the purpose. So sampling and population. Yes, so now the biggest challenge here, many of the behavioral research which are not we will not get a probability sampling. For example, if you want to understand the perceptions of customers, or if you want to understand perceptions of employees, or if you want to understand perceptions on stakeholders or anybody, that it is highly impossible for all of us to have a probability data in hand. That, when I say probability statistics or probability sampling, or random sampling, we can't apply, we can't get data like that, because you go to an X organization, can we get an information of all the employees and apply a random technique on that employees? It is not possible. So most of the times factor analysis, CFA will go with a voluntary sampling or a kind of what we say non-probability sampling. However, why I am telling this, it must be a representative sampling. Means if your stakeholders, if your study is on stakeholders, you should only collect data from the stakeholders. Many times what happened, that since I'm developing scale, I will collect data from anybody, any X and Y, and then I will develop a scale. No, because of that, we may face a lot of problems. That it should be representing your study. The data, whatever the sample or the population which you are referring, it should be represent. Like if you're developing a data, if you're developing a scale of employer branding, then definitely you have to understand. If you see title of one of my paper which I showed, from an employee perspective, that means why somebody mention employee perspective, that means the researcher wants to tell you that he has collected data from employees alone. Sometimes employer branding to develop such scale, that we need to also collect data from the top management who are the implementers of employer branding. So if you study from the perspective of the implementers, so you have your samples must represent only implementers. So as a researcher, we should be very clear about these things. We cannot say, you can't say that I collect data from employees, I collect data from management, and finally I developed a questionnaire. No. So the it must have a representing sampling, right? 1 second. Yes. So stages, organizing data over, displaying data over. So generally we do descriptive statistics. So why do we do descriptive statistics? To check whether data is normally distributed, to also check our missing values, outliers, and all these things. For that, we generally use descriptive statistics. Why do we use inferential statistics? To check if we are doing a correlational, understand the linear relationship between the cases which we are doing, or between the constructs, we generally do inferential statistics. So how do we present data? Yes, for factor analysis, that tables you should have a descriptive one standalone table where you can put all your descriptive statistics over there to show what is the skewness and kurtosis and all, and you need to give an analysis. When I am running the data screening process, when I run a descriptive analysis for the to check the you know to check the normality, that time I will explain how you should write analysis for this particular table. So to show the normality, if you say that my particular data or table is, or the element is normally distributed, to confirm that you should build a histograms like this for any of your one element, and you should show that your data is normally distributed. For that you have to represent some graph, only one or two sample graphs, particularly for thesis. May not be asked for a paper, research papers, but in thesis that definitely universities will ask what is the visual representation of your data, whether it is normally distributed or not. Like, these are the conceptual theoretical models, because see, when you have H1 H2 on these directions, those are hypothetical models. So when you are before maybe immediately after your literature review, you should have a conceptual models like this, that which shows the directions. So this is generally a directional model, which is forward, which is backward, which is connecting, which is the mediator. To give this representation, we have to develop such kind of diagrams. This is also important for thesis as well as for paper, that for any path analysis, you should have a conceptual model and a hypothetical model. So descriptive statistics, generally we see mean, median, mode, range. So why I'm bringing this, that we should know when we have a continuous data, means what is a continuous data? Maybe experience is a continuous data. When we have a continuous data, and when we see that there is some missing in the continuous data, we will replace those missing, impute with the means. But when we have a Likert scales data, like questions, and when we have missing, when we see some missing data in the questions, those missing data will be imputed with a median, which I will tell. That's why I'm bringing this descriptive stats over here, which is nothing but a central tendency. Even if it is not median, we sometimes also go with mode, but first preference given to median. Okay, so when do we say that the data is distributed? As we all know that mean is equals to median is equals to mode, which is called a symmetric curve. If median is not equals to median, median is not equals to mode, which is an asymmetric curve, where the data is not normally distributed. This is a simple understanding. So when you see your curves, tilting towards left or right, so it is confirmed that mean is not equals to median, median is not equals to mode. In that case, that it is not a symmetric curve and it is not a normally distributed data. So you should have curves like this. So most of your data has to be distributed under these curves, which I have showed it right here. Most of your data has to be distributed within this curve. This representation tells that your data is normally distributed. Okay. So this is for the standard deviation. As we know, the deviation has to be tightly clustered. So it shouldn't be zero. It shouldn't be too much. Like, you can't say I have a deviation of plus or minus 3. No, that is also too much. Even if it is 0, that means it has no deviation. So basically, the deviation has, we need a deviation. You can see this particular curve. This curve is not too flat, not too, even pointed also. It is little manageable curve. So this, like, if your curve is too sharp, which is small standard deviation, means your data is, the variance in the data is very, very less. But if in this case the variance is too high, so you generally need to have your data which is little balanced distribution. That's when your standard deviation is fine, good, right? So lipokurtic, mesokurtic, and platokurtic, here also that you should be in a position to understand your spread of data. This will help us to understand the homoscedasticity and heterogeneity. So if you have a linear curve like this and your data is too much spread, which is a platykurtic, which tells that your data is having too much of heterogeneity, which should not be. In order to run factor analysis, your data must be homoscedasticity, not the heteroscedasticity. So if you get curves like this too broad, that means there's a lot of heterogeneity. I will show how to run that. Okay, too much of lipocutic, platycutic is not suggested. Maybe it should be in a massicutic, curves. So yes, skewness, left, right, and the central skewness, as I mentioned. We need to try to bring our curves like this. In the first attempt for anybody, when we have a raw data and when we are running, that we may see this kind of curves. We need to, try to manage, slowly impute certain things and do some kind of, I don't call it as manipulations. It's an ethical manipulations, and bring data. Your curves should at least nearby should look like this rather than like this. Okay. Yeah. So I've completed with the basics. So I will give some space for 5 minutes for the questions. Anything related to this. And then I will start the introduction to the data screening process. Yes, any questions? No questions? Everything is clear? Is it too much or too less, or which you know already? Yes, no questions?
Madam,
Yes, sir.
I just to know, just to hear it once again about dispersion, madam, which slide you just shown.
Standard deviation.
Yeah.
Okay. I'll just
previous slide, madam.
1 second. I'll just. Yes.
Yes, last but one slide. Previous slide.
This one? This one, 1 second. This one? This is all
Yes.
dispersion only. Yes. What is the doubt?
Madam, what is the large standard deviation?
Means the standard deviation is plus or, for example, how do we represent mean plus or minus standard deviation? So 3.8 is the mean, plus or minus 1.2 is the standard deviation. Means 3.8 plus 1.2 or 3.8 minus 1.2, where the deviation is too much.
Correct. But madam, you also mentioned that it should not be 0 and it should not be too much.
Yes, that's what I mean to say. It should see the large standard deviation means it is too spread. The data is too much spreading. This is a small standard deviation means the data is very much compressed. So what I mean to say, in order to tell that our data is little normally distributed, it shouldn't be too spread. See, you can see over here in this, there is some spread. You can see over here and here. It's fine. But sometimes what happens, you see a lot of data over here. That is too much of spread. But your curve is only in the center, right? So if you get a very flat curve like this, that means your data spread so much, your standard deviation is too much. Okay, I will show you, sir, because in the data preparation process, we will use standard deviation in one place to tell you that how much distribution happened, which one to be accepted, which are the cases to be eliminated using the standard deviation. So you will get better understanding there. Okay. Any other questions before I close this slide? So that. We'll go further. If there are no questions, I will close this and then. Yes. Swati. Yeah, Swati. I'm taking Swati's question. Yes.
Ma'am, like suppose somebody wants to have a thesis most on like half qualitative and quantitative, like more of quant. So what are the least, like what is the maximum maximum testing which can be shown in that perspective on the quant side?
See, if your study, that's why my next thing is I have shown one model, right? Before, after I close this PPT, I'm showing one model, right? I will show that. That's my next discussion, Swati. I will discuss that. If I would have not answered your question, maybe you can raise this question once again. Okay,
Okay,
that's
ma'am.
that's my
Yeah.
coming discussion.
Okay,
Yeah,
thank you.
I have planned everything step by step because I know what kind of doubts generally, participants ask me. That's why I have my presentation in such a way. Yes.
Thank you, ma'am, for so much of explanation. Thank you.
Yeah, yeah. Yes, somebody else also want to ask me question before we move forward because we'll not come back. It is very difficult to come back. Yes, one question. Okay, I'm going forward. Yeah. So as Swati is also asking, and my next explanation is also about model, right? So this is just a simple model. So assume that this model, Swati asked question for thesis, but however, I'm just showing a model which we can use it for a paper, research article. And if a model is like this, I have a model where I have two input constructs, I have two mediating variables, I have two outcome variables. I hope this part till this point everybody knows, right? Input variables are nothing but my, my characteristics. First, antecedents. I can say it as antecedents. For example, what leading to what. So these are my independent variables. So usefulness. See, if I am closing this part, if I'm not considering this part, my usefulness is a dependent variable. But in this model, my usefulness is a mediating variable where information acquisition and the decision quality is the dependent variables. Okay. And what else? What are the information I have kept here? I have considered gender. I have made my age and frequency are control variables. Control variables are nothing but, I'm fixing for this particular study, age group of this. And these many times a person has to purchase a particular product to understand the playfulness and typical usage of a particular product. So I am keeping certain conditions, like these are nothing but an inclusive and an exclusive conditions. Generally for thesis, for all types of thesis, we use inclusive and exclusive criteria. Particularly for factor analysis articles also, we keep an inclusive and exclusive criteria. What is an inclusive criteria? Inclusive criteria is like if my study is on customers who use social media platforms, particularly Facebook or Insta page or something. So I will keep a condition that a customer must be using a Facebook at least for 2 years. A customer must have an account, must access at least once in a week. So if I give these kind of conditions to reach a particular respondent, those are my inclusive statements, right? That is my inclusive conditions. Exclusive statements that I don't want somebody who is lesser than 18 years. My study is not considering them, right? So that's because maybe your study needs an adult. Maybe if you are defined that your respondents, must be more than 18 years. So you will say that I don't want anybody who is less than 80, or you will give an yes or no that have you used this product before, or how many have you at least purchased this product 2 times in last 6 months. If somebody say yes, then only he will enter into your questionnaire, which is an inclusive exclusive criteria. Those are nothing but our control groups. So generally I keep a age restriction that I collect data maybe from age between 18 to 25. So that's my control groups. Frequency, a person must buy this particular product at least 3 times in the last 6 months. So I'm just giving a random example. So these are my control variables. Multi groups, I have considered male and female in this particular. So only gender I have used. And you can see experience here, which is also a multi group where I am trying to understand. So by seeing this model, in my questionnaire has included demographics of age, gender, experience, family background, income, children, all these things, right? My questions also have some other satisfaction, and I have a questionnaire of 30 to 35. Generally, researchers makes this biggest mistake, and they many people don't want to fill the questions by seeing some 40, 50 questions in the questionnaire because researcher believe that everything is important to collect data. So yeah, for thesis level, okay, I can understand, but for papers, no. It is better to have your questionnaire as simple as possible. Like what you should know by having a conceptual model in hand like this, what is required for your study. Age is required, frequency is required, gender is required, experience is required. Anything 1 or 2 questions you can add it into your demographics, not more than 5 or 6 demographic profile you collect. Similarly, that playfulness, some 3 questions like that you make it. And if it is for a simple paper, if you see my paper, I hardly have questions of some 20. That's it, not more than that. So why I'm telling data collection will be a difficult problem. That's when once the data collection having an issues, then your entire study will have an issue. You can't do how much ever manipulation you do, how much ever data you prepare, your findings will not be, too good. You cannot generalize because of that many respondents, unengaged responses, all these things, all these problems will come into the picture. So at least for the paper, you ensure that your questionnaire will have very simple and easy questions, easy understanding, the face validity, content validity, which I'm going to explain further. Those things has to be in place. So for this, if I say my demographics is experience required, gender required, age, frequency. So once I collect data, even the descriptive understanding also concentrate on the experience of these respondents, gender, age, frequency. So I limit what is required for my model. I will not do analysis which is not required for my model. However, there is a clause over here, note. For all the traditional universities, since they still have this mindset of having a huge thesis and they want, you need to represent in a Venn diagram, you also need to represent in a pie chart and then a tabular form and then a frequency charts and all. So no comments on such things. Generally, those are all redundant data which will not serve anybody's purpose, just will increase the number of papers. So if we are talking about good standard institutions, 100 pages thesis without talking all these things, we can submit. So that's my experience I'm sharing. But however, no comments, as I mentioned, that any traditional universities have a different requirements. You can go with as per your university norms and conditions. You can refer the old thesis. But for top class publications, if you're talking about an ABDC or a Scopus or a Web of Science, top class publications, you no need to explain about everything which is not required in your model. You need to only talk something which is required, which you are measuring, studying in your model. So that's why this model I have shown here. So for example, if this is the model and these are your hypotheses, enjoyment mediates the positive effect of playfulness on information acquisition. So this path, moderation and multi-group. If these are your hypothesis testing, if this is only your paper talking, you only explain about these hypotheses, test them, show the path and close it. That is enough. That's why I have given some simple hypothesis here. For thesis, yes. For thesis, you will have an hypothesis for playfulness, usefulness, all these things separately. You will have definitely some 10 to 15 hypotheses and you need to prove everything. But many times, we generally take part of our thesis for multiple publications, right? In such cases, you can, based on these 3 hypotheses, you will get one small model. That model alone you can make and publish. You can, even the data analysis also, whatever is required for that model, only that data can be analyzed and shown in the papers. Okay, I hope I have answered your question.
Yes, ma'am.
Yeah. Any questions here? When you develop models, what information to be put? I hope my explanation is clear.
Yes, ma'am.
Yes, thank you very much. Yes. Now I will start with the data screening. Yes. So before that, what I will do is, 5:15 is the time now. I will just show what and all I will explain. And then I believe all of you have downloaded the data set which I have shared. Yes, all of you having the data set?
Yes, ma'am.
Yes. So what is that I'm going to do with that? First things first, we should prepare the data screening. So I will explain what is data screening and I will do with all of you and I will show that. So it is better if you, not everything, not 100%, I can understand following me, doing it takes a lot of time. So at least 1 or 2, you just try with me so that you feel that satisfaction. Yeah, you done something today, right? So for that, I'm requesting. So these are certain things that we are going to practice today, the entire data screening process. What are we going to do? First, we do with missing data. We using Excel as well as SPSS, using certain things which I have highlighted. This anyway I have uploaded in the sheet, which I have written for yourself. Even any spelling mistakes, grammatical errors, please exclude such things. I've just written so that by end of the session, that if you open this doc, you'll understand what are the practical things that we have did today. So the second one is how to handle unengaged responses. Third thing is how to handle outliers. Under outlier, how to handle outliers on continuous data, how to handle univariate outliers and multivariate outliers. I'll explain what are univariate and multivariate. And the third and the fourth important thing is that, as I mentioned, that in order to do factor analysis, you must have a statistical assumptions. What are the most important statistical assumptions are the normality and multicollinearity. The data must not have a multicollinearity. The data must be normally distributed. The data must be homoscedasticity and linearity. These two are not very important. Generally, when you write paper, even in thesis also, that editorials will not ask you, have you checked the homoscedasticity, linearity and all, which is too much. But like tomorrow, if somebody asks you, that you should not think that I don't know about this. So I have got certain information. I even got some screenshots how to do that. So if you use my PPT, you can do that if somebody asks you, but however, I'll show it. That's not a big deal. So this is the flow for the next 1.5 hours. However, you can tell me in between that if you need a break, right? So yeah, we can plan. I can give you break at 5:45 sometime. For the first 30 minutes, we can start working on this missing data, right?
Ma'am,
Yes.
so the reliability testing and Cronbach alpha will come in this only, right?
No,
In this
no,
part?
it won't come here. This is data preparation. It will come
Okay.
in factor analysis, which I will tell you.
Okay, fine.
Yes. I will go slow, step by step. I'll ensure when you have data in hand, how to go step by step, everything I will explain, when to use, everything I will explain, okay? So that you don't need to have, you will not have any confusion, right? So I will open SPSS. Yeah. I will first open the PPT, the data screening part. Is my screen visible? Yeah. I think it's visible. I got a message. Yeah. Yes. Yeah. So data screening is not cooking data. That's what the first thing that I want to tell, that we are not manipulating data. We are trying to screen the data and clean the data. Any kind of redundancy, any kind of ambiguity we see, that we are going to see. And also, as we all know, that we cannot delete everything, right? When we have collected some 300 samples and you realize that there are some 15, 20 or some 30, 40 respondents having some issues. So you cannot delete all 30, 40 respondents. As we all know that those 30, 40 respondents is time, money for us. So without deleting the maximum responses, by doing certain imputation stages process, that we will screen the data. And also that, if the redundancy or if the issue is too much, only in such cases that we delete. Or else what we do, we will at least by doing the screening process, we can understand which cases may create some issue for us, and we will make a note of such cases. And when we are running EFA, exploratory factor analysis and confirmatory factor analysis, if anywhere if we see that the paths are just getting disturbed, or we are not seeing good factor loadings, in such cases we'll come back and delete such cases, delete these whatever the cases we have written for our understanding, and then we will rework. To go forward and backward, we need to do this particular data screening process. And it is very, very important. Without a data screening process, we should not go for any EFA or CFA. Yeah. Necessary screening we do: handling missing data, address outliers and influentials, meet multivariate statistical assumptions for alternative, for scales, normality and covariance. See, this multivariate statistical assumptions at a higher level, at an initial level, without without doing anything for your data, that just with the raw data, we generally do handle missing data and address outliers. Okay. So what are the statistical problems we generally see if we have, as I mentioned, that it will lead to a greater model complexities. To avoid those model complexities only, we generally do this data screening process. Logical problems, as I told that, like biasing, unengaged respondents. These are all certain logical problems that we need to avoid. So now what I suggest is, we have that data sheet, right? Yeah, I will open this SPSS. All of you have this data sheet, right? Yeah. What you can do is, first we will do simple things in the Excel, and then we will go and do it in the. So I'm just copying this entire data, open an Excel sheet. Yeah. Open an Excel sheet. Yeah. So I will just open one fresh Excel sheet. Yeah, I'll copy them here. Yeah, we can copy with the headings also. Copy with variable names. Right click and take if you want with variable names. Paste. Yeah. So we have data over here. First, that when you don't generally when you we should first when we have data with us. So first what we will do, we will check whether any missing elements or not. So how do we check? You can just count blank space. All of you can able to follow? You have the data with you? Yes? No? I want all of you to do this. So you can take up the range where I am excluding this ID. So I am taking everything, selecting, shift. I selected the entire data. Yeah, I'm excluding ID. So for the first case, I have 0, but however, there are some missing. So I'm just counting blanks. So I will just sort out this data, largest to smallest. Okay, you can see that there are 2 cells where we have the missing data. This is actually very important thing, that 2 respondents has not filled your questionnaire completely. So such kind. Yes.
Can you please the process once again, ma'am?
Yeah, that's why I'm asking you, please keep this sheet with you, this word sheet with you. You can go. So you have to just copy it in a Excel sheet. You type count, you have to count the blanks. You use a count blank function. So just is equals to, you can see it here. Yes. You can see it here, equals to count blank, and you can just go with select the range where you want to check, and once you check, once you just enter, you get that outcome, and you just sort it out greater to lowest. So because if you see these two cells, which are where these respondents, I'll show you who are those respondents. Employee ID. What are those employee ID? 303 and 288. So I will go to my, SPSS page, data view. I will go to that employee ID. Where is my employee ID? Yeah, where is that 288, right? So I will just go to 288. Yeah, I will keep my cursor over here. I just check. Yes, we can see all the empties here. Right click, you can clear this, right? Similarly, there is one more, which is 308. This is the simple, data screening process. So 303, I can see here, 303 is also having a lot of empties, right? Right click, clear. All of you with me? Can you able to do this? Yes, no?
Yes.
Yes. Okay. So we'll, even in Excel also, we'll delete this. 2. Okay. Now, once we come here, we also have few more, but all other places we have 0. That means no missing data. But we have at these stages, we have two missing data and 1, 1, 1. So let us understand what are all those missing data. Okay. So now when we have, see, in the previous stage where the missing data is 40, that means maximum of your questions were not unanswered. So we have deleted them. But can we delete even these things also? If we delete, including the 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it possible for a researcher to delete 10 responses in the first stage? Can we delete like that? Yeah, if you are too strict, you can delete it. But I suggest, no, we can do something. So how we can do, for example, if we see here age is missing in these two cases, right? So age is a continuous data. Yes or no? Yes, no, please. Age is a continuous data. When we have a continuous data, when there is a missing in the continuous data, we will impute with, which I have told when I was doing our basics. We will impute. How do we impute? We impute with
99.
means. Okay? We impute with means or average. So what I do generally, the moment I click on this particular cell, you can see here the average 21.65. Okay, I can impute here just without doing any SPSS. By doing a basic understanding, I can impute here 22 and 22, right? So just by considering the mean, right? I no need to do any calculation. Just put your cursor over here and check the average of this particular, column, this particular entire age group. And the average of this age group is 21.65, which you can impute 21.65, or you can straight away put a round figure of 22 years. Okay. So generally, if we have a missing data in continuous data, so continuous is nothing but age, education, frequency. In such cases, that you can impute with means, right? If we have a missing data in the Likert scale like this, okay, so I'm just trying to put my cursor over here. Here you got an average of 4.102, but we are not imputing with mean, right? As I mentioned, we should impute with median, right? So what I will do here, I will go to SPSS, okay. Zoom having this problem. Okay, yeah. What I will do here, I will go to transform. You can see replace missing values. Yes, all of you can see my screen, right? You have to go to transform, replace missing values. Okay, click on it. So what are the missing values you have here? Okay, before we do that, we'll just simply run one frequencies. So I'm just running a frequencies. Okay. So I'm just accept the ID part. Yeah, I will keep everything over here. Okay. And then my statistics, yeah, I'm not taking anything. Charts, if I want, I can take, but I will not take anything. Display frequency tables. Just click OK.
Correct.
Yes, I request somebody to mute, please. Archana, yeah, I'm muting you. Yes, Archana. Yes. Can you all see the outcome table? You can see this. What you can do is quickly right click, copy, go to your Excel, open a new sheet, just copy it over here, paste it over here, and just delete all the cells which are having 0, 0, 0, which we will not consider. Okay, for our quick visualization, I'm just deleting, delete. I'm deleting this, delete. I will delete this, yes. Okay, and I'm deleting all the zeros, delete. We're almost done. Yes, yes. So we deleted all zeros. So we have, these are actually our missing data. So we have missing data at 381.1, 381.1 at this cells. Okay. So now you can see here that this is age and this is experience. So these two we will replace with the means, and these we will replace with the medians, right? So now we understood that, right? We'll go to this here, and then we will again go to transform, replace missing values. So I'll select everything right now. So instead I select everything. So I have to check which question of mine that using Excel improves my work performance. So I just go over here. I'm just showing one example for you so that it will help you. You can do in one shot for everything. Okay. Using Excel. Yeah, I think the statement. I'm just pushing over here. Joy 6.1. So here you can see I'm just changing this name, Joy 6. Series mean. So since it is a question, right? So I want to replace with median of nearby points. So, and what else I have? I have using Excel in my work increases my productivity. Using Excel. Yeah, using Excel increases my productivity. So I just read whatever is required here. Using Excel in my work increases my productivity. I add it over here. I think we have done a wrong addition, which I will delete now. I will add one more related to the experience. So you can see here this one, since it is a Likert scale, that I'm only replacing with the median. Okay. I will just change that name. So I just use full _3, which I'm changing. And we also have issue with the age, right? So there are two things are there. As I mentioned that you can in the sheet straight away by checking the average, you can do that. Even by using this method with the mean, you can do that. Okay. So you can click OK. Like that, you have to select all these things. Take some time, properly read this statement, and then you can do for all in one shot. In one shot, you can do that, but I'm just showing you one sample for your quick reference. Okay. So I just click OK. Okay, it is replaced. You can check in your data sheet wherever it is replaced. Okay, any questions here? All of you can able to follow with me? Yes, no?
Yes, madam.
Yes. So I hope I'm clear because I will not stress much on this outliers. There are bigger things for us to discuss more. Okay. This is in the first stage. Okay. Activity. Yeah. So you all can see the process here, which is very much explained in my, this. You can check the missing and you can just replace. So what are the conditions here? As you told, missing more than 10% from a variable or a respondent is typically not problematic. Okay. So if it is anything missing lesser than 10, you don't need to worry. As I have mentioned, 2 respondents missing, 2 cases missing, it's still fine. Okay. We can still do that as I have mentioned. Yeah. As I told, the imputation method in the SPSS as well as in the Excel. So in the mean values, we can impute in the Excel itself. If we want to go for median, then we'll go to SPSS and we'll click with which method that we want to impute with median mode. So which I have already mentioned, if you are imputing data for your questionnaire, means your questions, Likert scale questions, you use median, which is the nearby. If you are imputing your continuous data like demographic profile or something, you will go with the average mean. Okay. So this is what something which I have shown right now. So there's a display here. You can follow that. Okay. Next, any questions?
Ma'am, hello.
Yes.
I think I know the answer for this, but still I just want to ask this question. Can we do this imputation of median, not median, especially for the ones which are missing data at the time of entering the reporting?
Yeah, we can do that. That's what I'm telling you, in the Excel only, which I showed you to do with median, mean, right? Average. Hello? Hello? Can you hear me?
Are you able to hear me, ma'am?
Yeah, now. So yeah, as I told you, right, when first when you have your raw data in the Excel sheet, even in that stage also you can do. But however, as I suggest,
I'm talking about while entering the data in the Excel sheet, that is coding the data only. That time I realized that there is a missing answer. Can I do it that time? I think not, right? Because you have to know the median first.
No, as I told you, right, you should know the mean and medians, right? So
Yes,
you can't. Yeah.
That's why I said I know the answer.
Yeah, we generally shouldn't do, right? It's like, you enter whatever you feel right? So that's like, again, a researcher's bias. Okay. So best method preventions, that generally what we should do to avoid the missing data, that I will read it for you here. You can see, as I told you, replace missing. Yeah. So now what happened in the thesis particularly, that you may not write about much of this missing information in the research articles, but you will write in your thesis, which is very, very important in the first screening when your thesis is more of scale development, or your thesis more of, this path analysis testing and all. In that case, what you do, you have to explain, like you must have collected some 300 samples where your questionnaire is distributed to 350 respondents, where 320 must have responded to your questionnaire. And when you properly screen your data for the missing, that you have identified, some two respondents, two respondents have completely missed the data, where you have deleted those two things, and other responses, like there are 8 responses where 2 of the responses have not responded the continuous responded age and experience, so which was replaced with the mean, and remaining 6 respondents have not responded one question. That question you can write and say that these questions they have not responded, which is imputed with the median. So this kind of an explanation generally in the methodology, in the pilot analysis, or in the data screening process, you have to report in the thesis, but I would not suggest for the research article. Okay. Now our next thing is unengaged responses. So how do we understand, how do we avoid this unengaged responses? First things first, that during your data collection process, you should ensure that there shouldn't be any unengaged responses. So what we have to do, we have to engage respondents. In between, there must be some intermediate questions like, so far, how is your analysis? How is your data submission going on, or some question? And by see that question, that if he is randomly given some continuous data kind of it, that means he is not engaged with the system. But however, you can't go back to that respondent and ask that you have not engaged. But as a researcher, to understand that whether he or she is engaged in answering your questionnaire, that for that. But the important thing is that if you have a reverse coding questions, maybe the first construct in the forward scale, in the second construct will be in the backward scale. If you have that reverse coding, yes, it is a good idea. That is why many times we ask research scholars to have a questioning pattern. There must be a change in the questioning pattern. All must not have, from strongly disagree to agree. Like second construct should be from strongly agree to disagree. So that we ensure that the respondent is little aware, at least at construct level, so that we ensure the engagement of the respondent. In the third category, that when we see that we should tackling the time, like in our Google Forms or in our when we are manually collecting, that if you know that to answer your questionnaire that it is required, you should know as a researcher that 10 minutes required or 15 minutes required. And if a respondent is not taking much time in responding, that means it's an unengaged. So which we have to manually do. So what is technically we can do is using a standard deviation. First, we have to do a manual observation. Like, you can just go to your sheet, just see like how your data is looking. Maybe unengaged respondents, like, I can see it over here at 6, 4, 4, 4, 4, 4, 3, 4, 3, 4, 3, 4, 4, 4, 4. So it's such kind of, data, if you see here, that they are little, it looks little unengaged, but visually we can't see, right? So how to check that, right? I have mentioned to one of the respondent that we will use standard deviation here to show whether your data is whether your respondents are engaged respondents or unengaged respondents. Okay, standard deviation P. Okay, I'm using this formula. You can all of you please check STDEV dot P, and I'm selecting my range, right? So I'm just selecting my range from only for the questions I'm selecting my range, right? Yeah, I'm leaving for gender and these things. Okay, till here. Oh, sorry. Okay, and then enter. So I got a standard deviation of 0.94. Yeah, it looks good, right? So now how will I say from this that I have few unengaged respondents? I will sort from smallest to largest. That you can see I have one respondent which is unengaged, 0. So you can see that he has given 3. Got it? So this is completely an unengaged response. So you can delete, right? And yeah, now you can ask me, ma'am, what is the range? So anything which is 0.5 and above, right? From here, okay, the responses are considered to be fine, right? But if you first, we will check the minimum and then we'll go with the maximum part. So if you see here, you have some kind of an unengaged responses from here, right? So yeah, again, end of the day, it is as a researcher's discretion that are you going to delete them or are you going to keep them? So at this point, I suggest let us not delete this, that we will just, this is 295, right? This is an employee ID with 295. So we can delete this 295 in the main data, but remaining, we will keep it as it is. But I even suggest the 19. This response also we can delete. We can see 19, 4, 4, 4, 4, yeah. You can see here 4, 4, 4, 4, all fours it has given, they have here given. So even this standard deviation is very too narrow standard deviation. You see a steep curve, what I was showing there as a display, right? So you see a very steep curves here. So I suggest if we say that out of 300 or 400 sample, if you have a standard deviation 0.5 and above, which is where the distribution, these respondents are engaged respondents. Anything lesser to that all these are little unengaged responses. Similarly, you will go to the maximum. Similarly, you filter, you say largest, okay, and you sort. Yeah, this seems good. Your standard deviation is 1.7, 1.4. Anything which is in the range of, yeah, within that 1 is fine. Even 1.5 is fine. That 1.7, only this particular response is too much. Means he must have the data. His response is so much scattered. In that case, you can see. Okay, so this is how generally we observe using the standard deviation. Yes, Vijay Krishnamurthy.
Yes, ma'am. I had one question.
Yes, please.
You spoke about for increasing engagement, different sections of the questionnaire you can change the Likert scale. For example, the strongly
Reverse
agree. You can
coding.
just coding, right? Is it only within? So, for example, if you have strongly disagree to strongly agree, can you have another one which is meaning the same thing, which could be like
Yeah.
less important to highly important kind of thing?
You can give, but only thing is what I suggest, order. If you change that order, no, that you can ensure little more engagement. So you can say for example, strongly agree. You started with strongly agree. Even the other set of like it is very likely, highly, I mean, more satisfied. That means the order is same, no? Both the order is same. Even in that case, also the respondent will be little biased. But instead, you say on top strongly agree, down you say highly dissatisfied. You start with high. The order has changed, right? You also engaging the respondent with a change in order as well as the keywords also, so that you can, he will be little mindful.
Yeah. So yeah, I get that. So that they don't, the monotony is broken, right?
Yes,
that's what you're
that's
saying.
the intention.
But I have the question that I have is actually at the top level. Now, when you're talking about correlating them, let's say the constructs when you're developing the model. But if we have slightly changed this for engagement, but at the model level, will there be any discrepancy or unevenness because of this?
No. See, you have to be, again, end of the day, you are changing it, but the meaning, the face and content validity of the question shouldn't change, right?
Okay.
That we should ensure. If the question is reading yes, no, your answer must be yes, no. It shouldn't be something else, right? If the question is asking you that, have you purchased this product twice in last 6 months, and you give yes and no, instead of yes and no, you can't give anything else, right? You can't give an Likert scale there, right?
Yeah, that's correct. The close-ended questions versus
Okay, so that open, you should be very clear that that face validity has to be maintained.
Okay, got it. Thank you.
Yes. Yeah. So I hope many of you must understood now why I have explained in the basics that kurtosis and standard deviations, how to see them. So that is the important thing to check the missing data, to check the engagement and all, we need standard deviations, right? So now I will go further. Any questions still here? You want break? We'll take a 10 minutes break. We'll join at 6 o'clock.
Yes, ma'am.
Yeah, okay. So I will start again 6 o'clock. Let us not stop anything. You can just, we'll start exactly by 6 o'clock. Okay. So I hope the flow is fine, right? Is it informative? You could able to learn something?
Yes, madam. It is very informative. Thank you.
Yeah, sure, sir. We'll just break for 10 minutes.
Hello, sound is missing. Voice is missing.
Excuse me, the audio is very, very poor. The audio quality is very, very poor. Not able to hear anything.
Yeah, same here.
Actually, we are on break. So I don't know. Maybe you must be missing in between.
Yeah. Now okay, madam. Now okay. Perfect. Thank
Not
you.
now, okay, that we are actually on the break. So I told that I will join by 6 o'clock. But however, I was working. I'm just working on my sheets. That's why you can see some moments over there.
Yeah. Okay. Thank you, madam.
Yes. Yes, we are back. I hope all of you are back again. Yeah, well, I'll just stop screening. Yes. So what are we discussing? I hope all of you are back. Somebody has to tell me that where we have stopped. What are we discussing? I was talking about, we just completed.
Missing data.
That's all. We also have done something else after missing data. Handling.
Handling the data.
Handling unengaged responses using standard deviation. Yes, all of you with me, right? Okay, I'll just see for one more minute, but however, we have a lot of things to discuss upon. I will start. So what we have completed in the data screening process, first we have discussed about, I'll share the screen. First, we were talking about the missing data. So I have shown you how to handle missing data in SPSS as well as in Excel data. In Excel, you can just use by checking the blank cells. You can understand whichever the data is missing. And if it is a continuous data, you can replace with the average. If it is a Likert scale, you have to replace with median. So you have to go in the SPSS and you can check and replace them using this particular procedure. Transform, replace missing values. So with the Likert scale, we will replace with medians. Continuous data, we replace with means. Okay. And then we were talking about the unengaged responses. By observing, we can understand, and by using a standard deviation formula function in the Excel, we can apply that this lowest, the less, even if the standard deviation is 0, that means there is no deviation. That means the respondent has given 5, 5, 5, 5, 5, all 5s. So there is no deviation. So such responses need to be eliminated from the process. And we have discussed about how to eliminate the unengaged responses, right? Now, the next important thing is the outliers and influentials. So typically outliers are of 3 types. So generally we call it as outliers can influence your results. As we all know, outliers affect the distributional assumptions also. So what are the 3 important outliers? I will explain, but however, first we will talk about the 2 important outliers. Outliers for the individual variables, outliers for the model. So when I say individual variables, a particular cell, right? Maybe a particular respondent for a particular question. If all the respondents has given a positive response, only one respondent must have given a negative response for that particular item. That is a univariate outlier. How we can check this? Using a box plots, we can check this, which I'm going to show. For a multivariate outlier means a particular construct, entire construct. For example, you have antecedent, like as I mentioned, the joyful, playfulness. So you thinking joyful and playfulness, both of them has to fall in a positive side. But however, most of the responses in the joyfulness has placed on the negative side. That entire construct is having some issue. That entire construct is reacting opposite as per your understanding. That is a multivariate outlier. How to handle that? Because that will generally affect on the CFA models, on the models. So we generally check the multivariate outlier in the SEM. So which I will not do it right now. When we are doing SEM, I will show that multivariate issue. But whereas univariate issue, we have to sort out at this stage, right? Going further, so this is how we generally detect a univariate outlier. So these are called box plots. So how to generate these box plots? So if you see here, we have our data. Okay. So we have to go to first thing is we need to, yeah. So if we see here in the variable view, you have playful 1, 2, 3, 4, 5, 6, 7, right? So how can you understand that for a question, playful 1, all your 300 responses responded in the same way or not? So for that, what you do is you have to just plot some graphs. You'll go to graphs. Okay. Graphs, and then you can go to a chat builder. Okay, click on chat builder, click OK. A pop-up comes like this. All of you can able to follow, right? So I have gone to a graphs and I clicked on chat builder. Once you click on chat builder, a pop-up comes like this. You just click.
Your screen is frozen, I guess.
No, it's not frozen. Can you see my mouse movements? Yes, no?
No, ma'am, we can see only your PPT.
Oh, let me share once again. Yes. Can you see now?
Yes,
ma'am.
Okay.
Yes, ma'am.
I will repeat this step. What I did is I have gone to this graphs. Okay. I selected chat builder. And once I select the chat builder, I clicked OK. There is a pop-up. So here I'm using the scatter plots. So I'm not starting with the box plots. First screening. I'm just trying to screen my data for my demographic profile. So I drag this scatter plots over here. So I got the scatter plots. So now I'm going to just understand, right? I keep on the x-axis the respondents, on the y-axis maybe the age. Okay, I'll put age on the y-axis, and then I click OK. Yeah, I select scatter plots here. That scatter plots I moved here, and then respondents and age. I click OK. This is for the outliers checking on the continuous data, right? So continuous data will be your demographic profile. So first we need to understand whether there are outliers on your demographics profile. Then we will go to our questions. Okay. So you can see an outcome page. So there is a scatter plot. Yes. All of you can see the scatter plot? Yes, no?
Yes.
So once I double click, the scatter plot will get activated. Okay. You can, yeah. So I just want to see the variable names options. So I have my variables here that yeah. So you can see here. Let me close all these things. Yeah, I'm not able to show anything. Yeah, just give me a minute. Yeah, so you have a scatter plot over here, and your scatter plot is like this. So there are few variables like this are little beyond, like not grouped together. So these are not outliers. These are actually fine within the range. but there are 1, 2, 3 elements which those are little outliers. So how are we going to check them? That we need to identify them with their IDs. Find the marker categories. Okay, you can check here that the element here, which is in between 42, somewhere in this is the number. So this particular respondent, we will go back to the data and generally we check at age. Okay, so we just go to age here and check who is acting as an outlier. Maybe somebody must have given a wrong age. So that observation we have to check it here. Okay, so because I have done so much, I'll go back. I'll just, yeah. So now what I will do here, I will just sort the age. Maybe I just give largest to smallest. Yeah. So somebody at an age group 35 with an experience of maybe the highest. So somebody who has an experience of 25 with an ID 291. So just that, like that. So somebody at an age of 21, which is showing an experience 25, which is technically not right, right? So this kind of outliers that we need to understand. This is only for a continuous data. Only at a continuous data level that we generally need to identify outliers like this. So if it is for a Likert scale point, if it is for a Likert scale, for the questions, so those are called the univariate outliers. So those things we will identify using a box plots. Okay, same procedure. That further, so we should first of all, what I mean to say that we should know what kind of plots has to be used for the what type of data. So for demographic profiles, you all can make a note. For demographic profiles, we should use scatter plots. For a questions, for a Likert scale questions, that we should use a box plots. Okay, so box plots also same. But here one thing we need to do. So what is that we need to do? We can't, for a univariate data, playfulness 1, playfulness 2, 3, 4, 5, 6, 7. These are all 1 question under playfulness, right? So we need to calculate mean for all these sum of means. We should get that mean to have a playful as a overall construct, right? So for that I need to do transform. I hope all of you know the transform. You have to compute here. I'll create playful. Okay. So what I will do is I will just add all the questions fall under playful. I will sum up. Okay. So I'm just calculating the mean of it. I just sum it. Before I do that, I need to calculate the mean. I'm just trying to group them. So that's what each construct. If I consider playful as one construct, all the questions fall under playful. I'm calculating the mean for that, and I will get means for all the items which comes under playful. For that means I'm going to check the outliers. That's what I'm trying to do this now. Right, and then I'm going to take the fourth one plus. I'm just transforming all of them. So we have 7 total. Plus the last one, right? I'm just one second. Yeah. So you can see over here in the data, one more column is added, which is playful. Okay. Whatever is that, we can edit if they don't want decimals and all these things. Entering data and all you must have seen in your previous, classes. I'm not doing that. So we'll go now, graphs. And now to get box plots, we have to go to legacy dialogues. To get scatter plots, we have to go to chart builders. Okay, I hope I'm clear here. To get different types of charts, that we need to go to chart builders. You will have all the charts over here. This you can do it. Okay. Legacy dialogues. I'm going to use box plots. So I'm just checking up single box plots. If you see here, summaries for group of cases, summaries of separate variables. So if I am checking, each question like this, I will go for summaries of separate variables, but it is redundant. You can't, for each question, it is too much, because when definitely in a questionnaire, you will be having 30 to 40 questions. Checking for each question is very difficult. So that's why I have calculated mean. So that's why that is called summaries for group of cases. So I'm just taking simple box plot, define. So I'm going to define what is my dependent variable. My variable is playful, which I'm keeping it over here. And then my category is, okay, let me go with response ID only. I'm just keeping my category access over here. And then, yeah, if whatever the options you have, you want to display groups defined by missing values, anything you can select, but as of now, I'm not selecting anything. I just want only a box plot. Yeah. To develop a box plots, we want the construct data. Since we have questions data, it is not coming. But anyway, I'm just trying to show it to you. We'll just see whether I can. Here I want respondents ID. Just I will take respondents ID as label cases. So let me take gender and see whether it will come, because there's a huge data. I'm just trying to see whether a box plot is created or not. Yeah, a box plot is created, but however, there are no outliers in the male and female. Yeah, generally in male, because we don't have any third category, there is no outlier. On male and female, as you know, this data, if you see by seeing the box plot only, we can explain that this particular data, whatever the selection we did, which is normally distributed, because the box plot is center. If the box plot position on the top side, which is at the which is skewed towards the left, if the box plot is positioned towards downwards, that is skewed towards right. But unfortunately, to show you the difference, the box plot is not creating like that. The box plot looks very good. So if a box plot comes like this without any outliers, that means this particular data is good. I'll just try to show that a box plot, it should come if there are outliers, a box plot comes like this. Okay, any questions? Because since I couldn't able to generate with that data some outliers, but generally, so if you see here, the box plot what we have got, which is positioned rightly in the center, right? This is the outcome which we have seen in our data. That means this particular, whatever the male female, for the playfulness, for this particular statements, for this particular construct, males and females, they have they have normally distributed. Their response is not too much standing in the outlier stage. But generally, if there are outliers, like this respondent 1792, 4939 and 3258, this could be IDs. We can take it. These are few outliers. These are few IDs have responded extremely different from the regular audience. So because of that reason, that these are considered as outliers. So generally what we do, if we see there are 3 box plots, we'll just see a number which is commonly distributed. That means most repeated. So in this box plot, if you see 4739, 4739, 4739. So this particular ID is repeated in all the 3 cases. Similarly, 3258, 3258, 3258. Even this is also repeated in all the 3 cases. So we can considering deleting that particular outlier. But however, as I have mentioned to you, it is not easy to delete every respondent. What we can do is we can note this particular code, keep it aside. After running certain analysis, there if that particular analysis, or if you feel that analysis is not significant or not coming as per your requirement, if you feel the errors are more, in such cases go back and delete this respondent and see whether there is a change or not. But at this stage you no need to delete, I suggest. But normally if you refer Andy Field or higher will say that you have to delete. Yes, you have to delete because that's the criteria. But as we all know that data collection is the most difficult part, that it is, we will not delete everything at this stage. We'll just keep a note of 4739 as well as 511 3258.
Hello.
We keep it aside. Yes.
Hello, ma'am. This is Rahul here.
Hmm.
If you take education as the filtering criteria, you'll get a couple of.
Yeah. Yes, sir. You can please try doing that, because what I mean to say, this is how it works. So my understanding, that's why I got some PPTs to show that if it is not coming. Okay. All of you can try, sir. You can tell what is the combination we can do, education with the playfulness.
Yes, ma'am.
Yeah. So maybe all the participants, you can try, instead of gender, we can try doing education with playfulness. Which are the common IDs that you can see over there, sir?
160 and 45.
So if it is repeating, so what I suggest at this point, don't delete. So generally textbooks tell you to delete it. But I suggest from the outliers, we have already deleted 2. After that, we have deleted 1. So if we, at every stage, if we keep deleting, then end of the day, once we complete the data screening, we will land up deleting some 10 to 20 responses, right? So we'll just keep it. So whatever that complete redundant respondents, anyway, we are deleting. Something which we believe that they may create some hindrance, we'll just keep it. We'll note those numbers. And when we are doing those combinations in the analysis, in the models, if that is affecting the models, in such case, we will delete. Okay, that is my suggestion. Out of experience, I'm telling, because when I am playing with data, it is very difficult for you to delete data at every stage. That's what my suggestion. Okay, in the next level, handling, this is univariate outliers. Multivariate outliers, we generally do it in MOS, right? This is in CFA. When we come to CFA, I will run this normality and outliers test and I will show it to you there. But this particular multivariate outliers, we will do when we are testing on models like this. I was talking about these path models, right? When we are testing these path models in the confirmatory factor analysis, in such cases, the next level of outliers, what we have to do it in the MOS, which is this particular information. When you are running MOS, you can check this as a second level of outlier detection, right? Process, right? You can, all the conditions were given here. We will do once we come to MOS. Okay, this is how it works. It will reduce and all these things. Best practices of outliers, best practice is always the removing part. But as I mentioned you, I will not suggest that at this point. Yeah. Now the important assumptions which we have come here is the normality and the multicollinearity. These are 2 important statistical assumptions. Before we start factor analysis, we should ensure that the data is normally distributed, that the data is not having multicollinearity. And yeah, homoscedasticity I will show, but it's okay. It's not too much important. But what is important is normality and multicollinearity, homoscedasticity and linearity, until unless editorial asks you. If it is like A star categories, and if your data is too rigorous, sometimes editorials may ask whether have you checked your data is highly heterogeneous or homoscedasticity, follow these assumptions. In such situations that you need to run once and show whether your data has homoscedasticity or not. So that I will show anyway. We'll just start with normality. So as I have already in my basics, as I have mentioned, that normality means you have to check your skewness and kurtosis. Can anybody tell me what is the range that you know about skewness and kurtosis which we need to maintain? Yes.
Kurtosis is between 3 and -3.
Okay.
And skewness is, I'm forgetting skewness.
Same.
Skewness, I'm forgetting.
So yeah, skewness and kurtosis both has to be maintained between ±3, but it will start from ±10, ±5, ±3. Even if you are too strict, you can go with ±1. I know it is very difficult. So where can we do this? Where can we see this? That you can just simply go to your descriptive statistics. You can just go to your data. With the zoom, this pop-ups on the top, it is very difficult to work, right? Anyway, analyze descriptive statistics, go to descriptives, okay? For what you want, maybe I'm just taking the first one, playfulness. Just go options. Importantly, I go with skewness and kurtosis. Continue. If I have any styles, I don't do it. I will just go with the yeah. Okay, but here you see you don't get histograms. So what we do is to also check the normality, we go with frequencies, because when we do frequencies, we also get the frequency tables. We also can see charts, right? So that's why I'm just trying to do frequencies. I will just put everything back and then I will just take only some 7 so that the loadings will be less comparatively. I click on the statistic table. I go skewness, kurtosis. You can even take mean, median, standard deviation, error, range if you want. Whatever we required. See, here many of you may have a doubt. Ma'am, what are the things that we need to keep? See, I suggest you, based on the journal which you are targeting or the university which you're working for thesis, maybe you can refer the existing thesis or papers. But generally, this central tendency, basic information with distribution and dispersion, standard deviation, variance, range, minimum, maximum, this information is fine. But when you run all these things, you get a huge tables. For thesis, it is fine. But for research articles, it is too much, which is not required. So I suggest in such cases that you can refer any good journal, any article which I have shown, right? So there's some simple tables that they have come out with. When you are running SPSS, you can generate table for everything. But when you are developing tables for the research papers, you just follow those patterns, existing patterns, and only keep that information so that will be useful. So click continue. You can go to charts. You can mention here histograms. Show normal curve on histogram. This is important. As I mentioned in my PPT, that when you are showing charts, there's a normal curve on the histograms, right? So that actually curve tells you whether your data is normally distributed or not. If there is anything, styles, format and all, you can check. So I just click OK at this point. Output is processing. You can see this distribution here. Okay. So all of you can see here the data is very nicely distributed. But this is little having that flatness. But by visually we can say that, see this particular table, I'm creative when I interact with Excel. This is actually normally distributed. See, all this depends on the researcher. If you are very clear, if you're having little experience and your data collection is going as per the plan, your data will fall like this. But if you are new to the system and you are doing for the first time or second time, and if you have not followed all the basic things when you are collecting data, that you may see skewness into your in your data like this. You will see your distribution curves little positively skewed, negatively skewed. this lipokurtic, platykurtic, generally we see in the raw data. But since this data or the data which I used for one of my study long back, so it's kind of little refined. So you can see a lot of all my curves are coming normally distributed over here. Okay, so and second thing, you can see the statistics table. I just go to the skewness part. So any issue over here, as you have already mentioned, plus or minus 3. So how will we calculate whether this is plus or minus 3? What exactly we should see is, where first thing, of course, the plus or minus 3 condition is always there. But however, we have to check with the standard error of kurtosis. Similarly, the skewness. For example, if the standard error for this skewness 0.125, if it is squared 0.125 into 125, if that 0.125 if that square is greater than 0.291, then there is a skewness issue. If that is not greater than 0.291, then there is no skewness issue, even in the same case. But here you see there could be a kurtosis issue in this particular response. But in the second case, you see there is no kurtosis issue because here the kurtosis is 0.804. So if 0.249 multiply into 2, it may come at 5. So 8, the second question is not having an issue. But the third question is again having some kurtosis issues. Even the first question is also having some kurtosis issues.
Ma'am, is it square? Sorry. Ma'am, it is squaring or multiplying by 2?
Sorry, multiply by 2. Sorry. Yeah, I'm very sorry. Yeah, multiply by 2. So if you multiply this error into 2 times, and if that value is greater than your kurtosis, then there is a kurtosis issue. If that value is not greater than your existing kurtosis value, then there is no kurtosis issue. This is at a basic observation level we should have. But however, as I mentioned, that if your kurtosis values are not greater than 1, we no need to worry. If your values are 1 point something, 1, 2, in that case, yes, absolutely. By that time, you can see some skewness in the charts like this. Since here, none of our values are at point, 1 and above, so we don't have any skewness issues. So, but again, as I mentioned, that if it is crossing 1, that itself is a an alert for us that we need to go back and check each question for any kind of an outliers or for any kind of missing data or for any kind of unengaged responses. That situation, or else whatever the numbers we have identified in the outliers, right? Those numbers you can delete and check. Like that, we need to go forward and backward when we are running data, right? So yeah, this is the normality part. Any questions still here? My PPT explains everything step by step. Yes?
Ma'am, we can't test multivariate normality here, right?
No, we can't test here.
Okay, ma'am. Thank you.
Yes. Yeah, all this I explained, right? Multivariate normality we can only test when we are testing on the constructs. Here we are only having questions, right? Items, single items. So in single items we can't do. When will we do multivariate normality? When we are doing groups. So there, if I have shown you, right, this part. That's why I have captured this screenshot here. You can see in the SAM, you can straight away check test for normality and outliers. That is for the groups, multivariate. Yes? You can try this for the multivariate.
Ma'am, can we add that thing the way you showed earlier, the way you prepared the playful construct, add it and then check for its normality? Is that possible?
We can check, sir, but however, for example, if one item is having an issue, how will you identify? And
then it's
also,
difficult. Yeah,
and also
right.
playfulness, only one particular construct I have transformed, but I need to transform the entire model, right? And then I have to check using a regression.
Yes, ma'am. Thank you.
Okay, using a regression, we can do that, but I will not tell because this will be too high end. I want all the respondents to first start the factor analysis and then go little high. Yeah. So these are few issues I have told here. See, if you have a fixed flat distribution, if your distribution is flat, what you have to do is, whichever the question or a item which you are considering, that particular item, you divide it, you put 1 by x. That value has to be kept in the x, and you manipulate that data, you impute, transpose that data, and then you check. For the negative skewed, you have to square that x into x, and that data you can, like this is transpose only. For example, your item 1, if you are considering, and your item 1, that playful item 1 is having some negative skew. In that case, what you do, that particular item, you multiply x into x, and you generate, transpose that entire information, and then you run again a normality test and see whether your skewness is distributed or not. If it is a positive skew, you have to do a square root of whatever the x you are doing. So these are few fixtures which we have given. But again, end of the day, when we are playing with data, it is permutation and combination. I cannot say that this particular method will solve it. It's like we need to keep on, because we don't know which particular element or which particular item is disturbing this entire flow. For that, as you have to very seriously concentrate on your data, understand your data, and do forward, backward, and check how it works, right? Homoscedasticity is a nasty word that helps impress your listeners. Yes, that's true. As I mentioned, even editorials also will scare you by asking such kind of questions. And then we, as a researchers, we don't know what is homoscedasticity, how I need to understand. Even here also, you should have an independent variable as well as a dependent variable on x-axis and y-axis, and you can check homoscedasticity, right? How I will just show it to you. So actually, this is a simple scatter plot, since we don't have those groups. So for that, there is one playfulness we have. And as per our model, what is the other thing which you can compute? So you can compute decision quality. Playfulness is our independent variable. You can compute decision quality with the means. So you get playfulness as well as decision quality. You can go to, I'll just show you that path, although I have not done the compute, but you all can try doing this. This could be your practice. You can go to analyze, go to regression, linear regression. Okay. You can keep your dependent variable and independent variable. So you can keep your dependent variable as decision making. You can keep your independent variable as playfulness. And you just go with the plot. You go with normal probability plot or histograms. Here what you can do, you can keep your dependent on the x-axis, sorry, y-axis, and your z residuals. Please make a note of it. Z residuals on the y-axis. Since I don't have decision making, I couldn't do that. You can compute it, because I showed you how to compute the playfulness part, right? You compute for decision making. So your decision making is your dependent variable. Your playfulness is an independent variable. After you select that, a pop-up will come in the plots. Here in the y place, you please place your dependent. In the x-axis place, you please place your z resistance. When you place this and click continue, okay, and click OK, you will see this kind of a plot. Okay, you see this kind of a plot. So how to interpret this plot? For example, if your linear line is this, we assume that all your items has to closely fall near to your linear line. If the distribution is too much like this, that means it is not having, it is high on heteroscedasticity. It is low, it is not high, it is low on homoscedasticity. So it is like, if I say that, if I need to confirm that my data is having this homoscedasticity, that, this for this line, all my elements has to be closely, fall into that. But here you see the, the distribution is too much from here, from this line to this part, right? So since it is too much, it is, I'll write 1 second. So if my line is this, from here, if I draw a line, so this distance is too much, right? So that means my data is having too much of heteroscedasticity. Means what is it? I have a too much of scatterness in my data. But if you have on the x-axis, I will draw and show. If your line is like this and all your points has plotted in this area, only within in this range, okay? Only 1 or 2 points just like that plot here. In such cases, that my data, I have satisfied the homoscedasticity consideration. Okay, that's how it works.
Ma'am, is there a number?
Will you all practice?
Hello?
No, sir. It's like, see, in this case, the scatterness is too much, right? So this is dangerous. But the example which I have given, the scatterness is completely less, right? Maybe some 10 or something. So that is not dangerous. But this is dangerous.
Okay.
There is nothing like no limited numbers or something that, but this kind of, if you get in your data screening process, if your data is distributed like that, I can say, excuse me, I can say that your study is highly in risk.
No, my question was, is there any parameter number? For example, let's say you have put the R square. So R square is within this range, height, heteroscedasticity. Sorry, that
it's
twister.
Homoscedasticity and heteroscedasticity. Homoscedastic and heteroscedastic. Yes, sir. See, generally for these things, for homoscedastic, the R square must be less. That's what I mean to say. For heteroscedasticity, the R square must be more.
Okay, ma'am. Thank you.
Linearity, this is simple pair means, but it's not required. Most of the times it won't ask, but for your reference, I have given it in the slide. You can check this. Just you need to conduct a simple difference between means and check test for linearity. It is very clearly given here. You should not get a significance value. If you don't, if your whatever the significance is greater than 0.5, that means your data is linearly distributed. If it is less like this, that means that particular data is not linearly distributed. This is also one test for that, which is not required. But what is required is your, again, multicollinearity. This multicollinearity, this is influential, like playfulness, decision making. And one more element, if I see, like if playfulness and joyfulness both are, influencing equally, or influencing, having some kind of a duplication, multicollinearity on decision making, instead of playing both of them as an independent variables, if both of them are overlapping, in such cases we generally check multicollinearity. Again, the conditions for multicollinearity is if the VIF value is lesser than 3, no problem. If it is greater than 3, there is a potential problem. If it is greater than 5, very likely a problem. If it is greater than 10, then it's a definite problem. So again, here also, since our data is not having that, 1 second. So I'll just show you where you can get this multicollinearity statistics. I'll close this. Again, you can go to analyze. You try these two things by composing, by creating 2-3 group of variables, and you please try, because the more you try, you will have better understanding than me, because I will tell all these things because I've been doing this from years. For your understanding, you have to keep your dependent and independent variables in the options. In the statistics, yeah, you can see here collinearity diagnostics. This collinearity diagnostics, if you select, you will get an outcome. That outcome will show with that VIF. If your VIF values are within the range of 3, that means there is no collinearity issues. But if it is greater than 3, there is a collinearity issue. 5, 10 and all, you leave it. Anything is greater than 3 is having an issue. That's it. So click continue and click OK. You will get a table with the VIF scores. You try these two things so that it will be helpful for you. So you will get a table like this. You can see this. My PPTs are self-explanatory. You can understand. Yeah. So I'm done with the data screening part. Any questions? Because before you start with factor analysis, you have to do thoroughly with your data all these basic things and ensure your data is cleaned properly. So I think I'll not start PC.
Madam, I am asking a very basic question.
Yes, sir.
See, all this we will do, but why should we do factor analysis? What is the advantage of doing factor analysis?
May I
in
know
my
who is
research?
this?
It's a very basic question, but
Because sir,
still I have a doubt.
you did not attend my
Yeah, madam, you are
session from
asking
the
something.
beginning. You did not attend my session from the beginning.
I missed some part, madam.
Okay.
Yeah, some
Because
part
I
missed
have
actually.
very clearly
But if you can
explained
summarize
in the
in
beginning.
just
Yes, I will do that. So basically, if you
if you
open
can
my
summarize, it will be nice.
Yes, sir. Yes, sir. So if you open my folder which I have shared 3 different papers, right? One paper is all about the simple, model, simple path analysis, and other 2 papers on scale development, right? So in order to make your whatever the models you develop or the scales which you are going to develop, if you want to generalize them to the large audience, and if you want these scales to be used by multiple people, like even in generations, you have to develop these scales with kind of a authenticity, with kind of whatever you want to measure, with the face and content validity, all these things. So in such cases that you have to do you will generally do factor analysis. Factor analysis is basically we will use when we want to develop scales or when we want to refine the existing scales. So there is a joyful scale which was developed in 1960s or 1970s by X person. For maybe that time, whatever the sample he has taken, those scales might suit to that generation. Maybe today joyfulness could be different for this generation. If you want to add 1 or 2 items and you say you want to tell that this is the joyfulness scale for which is more suitable for the current requirement for this particular sector or for the current generation or for this particular group. So how will you tell that your scale is scientifically tested and proved? For that, you generally do a factor analysis. I hope I answered.
Hello.
Yes.
Yeah. Ma'am, my question was earlier I posed the same question. Now the scale is already tested. Then can I directly go for confirmatory factor analysis?
No, I have mentioned no. Although if the scale is already tested, without doing an exploratory factor analysis, without doing the data screening process, you cannot straight away go to a confirmatory factor analysis. Is because the scale is developed in a different context, different sector with different set of respondents. Although it was communicated that it is generalizable, but with your data, with your respondents, with your context, it may deviate. A particular question, a particular item in the existing scale may not be suitable in your context. So to understand this, you have to do EFA, because in the exploratory factor analysis, based on the factor loadings, you are going to go forward with the elements. For example, the scale is having 5 items, 5 questions, which was the developed scale is having 5 questions. But in your context, there's one question which has a less factor loading, where the correlation value is 0.1 or 0.2, which has very less factor loading. That means that particular item is not relevant in this context, in the context which you are studying. But even though, since this is a tested scale, I'm straight away carrying into CFA, your CFA will get disturbed and your findings are not generalizable. That is the reason no editorials will accept papers without conducting an EFA.
And the reason I'm asking is the factors will not load properly if I'm doing an exploratory. But in confirmatory, because the model I know and it is as per the theory.
No, sir.
The factors will load accordingly.
No. That's not the, I don't know. That shouldn't be your understanding, because see, as per the theory, you have taken the questions, I agree. But the respondents will not respond as per the theory. Respondents don't know your theory, right?
Yeah.
So to avoid that bias only, we as a researchers are between, because we are the person who know what is the theory. We are the persons who know what is the reality, right? To clear such kind of confusions only, we will follow the procedure.
Ma'am, in the Ritika paper which you showed, has she done that?
Yes, definitely. Anybody will do. But it's only, sometimes they will report, sometimes they'll not report. But 90%, 99% of the times, research papers, that to top, see again, you take a simple review paper which is published in some peer-reviewed journals and say, in this paper it was not referred, but still it is published. No, I am not answerable for that. If you are really targeting some good journals, which are indexed in top
But the reason I'm asking is that Ritika paper I've referred because it is relevant to my research, and in that I don't see any exploratory factor analysis.
They will do, sir. Definitely they will do. I will also tell you, when we are running principal component analysis as well as EFA, I will tell you why EFA has to be done when you are doing CFA. I will tell.
Thank you so much. Thank you.
I will tell. Don't worry.
Thank you, ma'am.
Yes, sir. Yes, I can take any questions, or else I will stop now, because if I start again factor analysis in 5 minutes, I need to stop today. Tomorrow I will start the entire factor and EFA, exploratory factor analysis, and the difference between exploratory factor analysis using principal component analysis and principal axis factoring. These two I will explain tomorrow. If all of you have no questions.
Excuse me, ma'am.
Yes.
Ma'am, for first paper, what you showed, so in that you have created one simple model. So for that, what type of the questionnaires we need? Like if
you can same thing you check in that paper. I have given the questions also.
Okay.
I have mentioned those items. I have written in the description. This is a Likert 5-point Likert scale. In this category, I have measured. Everything is written.
Okay, ma'am. Okay.
Yeah.
So I'll go through that. Thank you, ma'am.
Yeah, I request all of you to please possibly go through those 3 papers, at least not complete reading, just glance it, because tomorrow, although I give you some examples, I'll give you some data to work on it. But if you know, it will be more easy. And whatever the data screening data which I have given, please do some permutations, combinations, and check the outliers, check the missing data, everything. Follow the instructions, and see to that you can do data screening clearly. Yes, I'm done from my side. So this is the Word document which I have dropped for you. You can check what is the procedures. Anywhere if you miss these steps, you can check this. You can even refer the PPTs, everything. Okay, thank you. If there are no questions.
Thank you, ma'am.
Thank you, ma'am.
So it was an informative.
Sir, I'm not able to listen. Your voice is completely cracking in between.
No, I'm telling it was an informative session today.
Oh, thank you very much. If you feel it is informative, you learn something. No, I planned in such a way that I will put forward a simplest EFA and CFA. I don't want to put a complex EFA, so that after the sessions, nobody will pick up this. Many times it happens. So I don't want to do that. So my intention is very clear. I want to make it as simple as possible. Yes, thank you very much. Thank you, Amit, also for your message. Thank you all. Have a great night. Good night to all of you. Tomorrow we'll meet. Bye-bye.
Bye. Thank you. Thank you very much.
Yes.